Right. Good morning, my dear students. Let us conclude on our previous topic of chlorine and its compounds. And soon after this lesson, our next interaction is going to be on the chemistry of sulfur. So I want you to prepare for the chemistry of sulfur. So we are at the last content, preparation of salts of hydrochloric acid. Each time we look at a topic, we end with the salts that push us into qualitative analysis. So I want us to look at the salts of hydrochloric acid. We have two types of salts of hydrochloric acid. So there are two types of these salts. So the first category of these salts are the salts we call the soluble salts, which means I look at the soluble chlorides. So we are looking at the soluble chlorides. And after soluble chlorides, what follows next? Insoluble chlorides. We have what we call insoluble chlorides. So in our chemistry, to make work relatively much more cheaper, if we can look at insoluble chlorides, then you can predict and mention all types of soluble chlorides. The only insoluble chloride we have here is silver chloride, whose formula is capital A, small g, capital C, small l, that has a tail. So there is somewhere, somehow, which I want to bring as Roman 3, though we count it under Roman 2, what we call sparingly soluble. Sparingly soluble. Don't say, now you are writing 3, but you say there are 2, because these two, Roman 2 and Roman 3, are merged together if we are looking at solubility at room temperature. So this slightly soluble chloride is what we refer to as lead 2 or lead 2 chloride, whose formula is capital P, small b, capital C, small l, and 2, because lead has a valence of 2, chlorine has a valence of 1. When you interchange, you get this. So these two, in most cases, we batch them together. That's why I'm saying there are two types. Therefore, what are the common two types? Soluble and insoluble. But among the insoluble, one dissolves to a very small extent and refuses to dissolve. For example, if I prepared a meal and I'm inviting you to come and eat, there is one person who will sit down and enjoy the meal to the last part of it. That one has eaten. Then there is one who totally refuses to eat. Then there is one, if it's rice, maybe you scoop about 2, 3, 4 spoonfuls of rice and you stop eating. So in African culture, I'm right to say you have not eaten, because you have merely tasted, which you call pexing. Pexing is not the same as eating. So if you have pexed, it doesn't mean you have really eaten. So when you count people who have not eaten, we count you among people who did not eat, because you merely did what? Tested. That's why these two are being batched together to constitute the second type, the insoluble salts. However, among the insoluble salts, I want to clarify to you that one dissolves to a very small extent. So lead 2 chloride is slightly soluble. And we shall note that this salt here, particularly, it is insoluble in cold water, but it dissolves in hot water. Dissolves in hot water. So I am right to call it insoluble if we are looking at cold water at ordinary temperatures. So it becomes insoluble. So think of another chloride. Think of another chloride. Where does it follow? In the category of soluble what? Chlorides. Think of any other than these two. For example, even if I thought of a certain name. Let me think about a salt called Untitled chloride. So Untitled chloride, if at all there is a compound that is called Untitled chloride, what do you know about this chloride? This chloride is soluble because it is not silver and is not lead to chloride. So think of any chloride. So in your chemistry, you know so many chlorides. All these chlorides, therefore, by virtue of today's lesson, are soluble chlorides. So let's look at typical examples. Let us follow the reactivity series. On top, we have potassium chloride, followed by sodium chloride, followed by calcium chloride. After calcium, magnesium chloride. After magnesium chloride, aluminium chloride. After aluminium chloride, there is zinc chloride. After zinc chloride, iron. And we have two types of iron. Iron 2 chloride and iron 3 chloride. What follows next after iron is now lead, which is here out of the system. Out of lead, from lead, we come to hydrogen. Hydrogen chloride. We already know it. But since hydrogen is not a metal, we shall not call it a salt. So we leave with that one. And from there we come to copper 2 chloride. And what do we go next to? Silver, which is outside here. But beyond this, there are other chlorides that are not mentioned here, but you know them. What are they? Things like barium what? Chloride. Is a special chloride we bring in, though it does not appear among the reactivity series. So all these chlorides are soluble. The only insoluble chloride is silver chloride and lead 2 chloride. Alright? So what are we capturing? We are capturing the following. You capture that there are two types of chlorides. Roman 1, soluble chlorides. Roman 2, insoluble chloride, and sparingly soluble chloride. So we shall say insoluble chlorides. We shall list the two insoluble chlorides, silver chloride, and lead 2 chloride. However, we shall note NB, the formula is PbCl2. So let us note that, however, PbCl2 is insoluble in cold water, but dissolves or is soluble in hot water. So all of us, wherever we are, you note that statement. Can you quickly write down the statement and we continue, because we shall need it for qualitative analysis. Alright? Are you throwing the container? Yes. Alright, so we shall begin with preparation of soluble chlorides. So let's begin with preparation of salts. We are told that in the last 20 minutes you shall be having interaction. So prepare your questions, you'll ask them in the last 20 minutes. So preparation of salts of hydrochloric acid. Preparation of, let me just add this word here, preparation of salts of hydrochloric acid. Now, we shall review several methods of preparing salts. We have majorly 3 types. So, salts can be prepared by Roman 1, direct combination. So direct combination of what? Direct combination of chlorine with the metal. Direct combination of chlorine with the metal. And this is one method. So if I look at, mention different types of methods of preparing salts, you just end on direct what? Combination. Now we are adding chlorine with a metal so that we end up getting a respective compound that we want. So this one is going to be true for all salts except, so what are the exceptions? This is except, except, before we come to that one, we rule out 2 first. Except silver. So except silver and lead. That's the first exception here, Roman 1. So, can you tell me exactly why? Why that method? Why can't you take that method? I have some people in the studio, they'll mention the answers for you to come in later. Why not that method? Why can't we combine chlorine with these metals directly? We said lead 2 chloride and silver chloride are insoluble. So the reason is the reaction doesn't take place because the salt being formed is insoluble. So we shall have lead outside being coated with a layer of a chloride and stopping the reaction from further taking place. So why? This is because lead 2 chloride and silver chloride are insoluble, thus form a protective what? A protective layer. Yes, that prevents or that stops the reaction from further taking place. That stops the reaction. So we are ruling that one out. The rest we shall combine. Roman 2. What can we also prepare by direct combination? We cannot do this with sodium and potassium. Sodium and potassium. Again, why? It is very possible, but this time we shall not try it. Why? The reaction is very explosive. Reaction is explosive. We mentioned some of these things before we ended. So who are the people who are left to react in the reactivity series? We shall now have calcium, we shall have magnesium, we shall have zinc, we shall have iron, but we form iron 3, but not iron 2. We can think of copper, you can think of barium. So this is possible. But now, can we go ahead and identify the conditions required in order for this reaction to take place? It involves passing. So what do? We must pass chlorine. Let us say dry chlorine. Let us be specific. We should not leave room for an error. So we shall pass dry chlorine over a heated what? over a heated metal. So my student can now sit down and write all the possible reactions and all the possible processes. So what do? Pass chlorine over heated magnesium. What do you end up with? Magnesium chloride. Pass chlorine over heated copper. Dry, you end up with copper 2 chloride. Chlorine and iron, iron 3 chloride. Chlorine and zinc, zinc chloride, and so on. So with this preamble, my students are covered. They can sit down and complete the work. I am therefore saying the assignment to be given, having noted, by the way, if you have not noted this, you rather note it down. I'm giving you just 2 minutes or so to note that down, and we continue. Direct combination of chlorine with the metal, except lead and silver. Lead chloride and silver chloride are insoluble. Thus, they form a protective layer that stops the reaction. Second thing you are noting, let me write the second aspect up here. So Roman 2, we are saying potassium and sodium. So what's the reason? This time we're not saying because they are insoluble, we are saying the reaction is explosive. The reaction is explosive. So we shall not take a risk. We have said down here, therefore, to prepare our salt, what are the conditions? Conditions to prepare these salts. Conditions. You note that we need dry chlorine is passed over a heated metal. So this is what you have written down. I'm therefore calling upon all of you as your assignment at the end of the lesson and after the end of the discussion to write equation of reaction between dry chlorine and the following. So assignment. I'm writing the assignment up here. Assignment. If there is any problem, you'll present it tomorrow or the next time we're having a discussion. So assignment. Write the equation of reaction between chlorine and A, zinc, B, magnesium, C, copper. So that is what we have as for now. let us venture into method number 2. Method number 2 is a method of neutralization. Neutralization. Sometimes we call it double decomposition. So what does it involve here in neutralization reaction? This is going to involve reacting an excess solid, i.e. metal, metal oxide, metal hydroxide, or metal oxide, metal hydroxide, or metal carbonate, or a metal carbonate. With excess, not with excess, with dilute hydrochloric acid. With the dilute hydrochloric acid. So pick a metal. Instead of adding chlorine, this time we shall add hydrochloric acid. You pick a metal oxide, hydrochloric acid. You pick a metal hydroxide, hydrochloric acid. You pick a metal carbonate, hydrochloric acid. So where are we? We are back into the properties of hydrochloric acid. Back into the properties of hydrochloric acid, which we have already covered and we're comfortable at that level. Alright? So I want us to rewrite the following summary scheme, and that shall go into the basic essay of preparing a salt. From the summary scheme, we shall go into the basic essay of preparing a given sample of a salt. Alright, so what do? We have a metal plus, which acid are we using specifically? Hydrochloric acid. Hydrochloric acid. So what do we get? Do you remember what we obtained? What did we obtain? We obtained a metal chloride. Metal chloride plus hydrogen. Again, this metal will not be sodium. This metal will not be what? Potassium, for the same reason. So what's the exception? So here the exception is we are removing sodium and potassium. For the same reason, the reaction being explosive. However, other metals, it's okay. So what are we removing? We are removing those ones for that reason. What else should we remove? We are also going to remove lead. And what? Silver. What's the reason this time? Insoluble. We shall also remove copper. So what is the reason? Why are we removing copper this time? With the chlorine it was okay. With the chlorine it is okay. Why is it that with the hydrochloric acid we are saying copper is out of the system? What do you think the reason is? Look at the position of copper in the reactivity what? series. Here we say reaction is explosive. I accept it. Here we say the reaction is going to give insoluble salt. I accept. What about here? This time copper is below, is lower than hydrogen in the electrochemical series, so displacement cannot take place. You can think of another equation now and write, but we are refusing these 5. So that is category number 1. Category number 2, we are thinking of metal oxides. Metal oxide plus our acid hydrochloric acid, hydrochloric acid. What do we obtain? Metal chloride, and water. So let's pick out what's the exception here. What's the exception here? The only exception is lead 2 oxide and silver oxide, if it's there. And in most cases, we don't have silver oxide. So it's only that one we're picking out. This time copper oxide works very well. It's a basic oxide now. This time it will work. So don't say, but here we say the copper. Now here what is wrong? An oxide of copper will work this time. And even the lab qualitative analysis, sometimes we give you copper oxide dissolved in acid and investigate the cation present. So can you think of a metal oxide? I've not written sodium here, I've not written potassium because those oxides are there and they're very what? Stable. The reaction is no longer what? Explosive. Don't say silver oxide works. Silver oxide is not going to work because that oxide actually we don't have it. But it is okay for purpose of not getting lost. We can put it there. Fine. No problem. So what do you think is part C?
Metal hydroxide.
It's a metal hydroxide. So what are we adding? Hydrochloric acid. So what do we obtain? As above, we have a metal chloride and a water. Exception? You can now get the exception alone. What's the exception? PbOH. Lead 2 hydroxide and silver what? Hydroxide. Why? Same reason. Insoluble oxide. The rest will go through very well. So if you know the metal, you can write the equation as long as you know the what? The valency of a metal. It's wonderful. So allow ourselves look at part D and we'll go into the general scheme. Looking at the strength of events we may not have enough time to go through these things finally in senior as you are preparing for your exam. Shall be just hinting on them. That I'm taking a lot of time now so that you can probably internalize them as for now. So what is number D? Number D is metal what?
Carbon.
Metal carbonate. Wow. So metal carbonate plus hydrochloric acid. What do we obtain? Three things. Number one, metal chloride of your own choice. We shall have water. We shall also have carbon dioxide. So what do you see this time? Bubbles of a colorless gas. This reaction is very common in a practical. So please, as usual, who is going to be left out? We are going to leave out lead 2 carbonate, and we shall leave out silver carbonate. So my question is, outside these salts, I'm back in gas preparation. I'm asking, why don't we prepare carbon dioxide by reacting hydrochloric acid with lead carbonate? After all, your chemistry of senior 2 tells you metal carbonates plus acids give us salt, carbon dioxide, and water. So why can't we prepare carbon dioxide in the lab by reacting hydrochloric acid lead 2 carbonate? So the two will react to give you lead 2 chloride. So we shall have PbCO3, a solid, plus HCl, which is aqueous. What do we obtain? We shall obtain PbCl2, solid. What else will be given out? Carbon dioxide. What else will be given out? Water. But because you are forming this compound, lead 2 chloride is insoluble, it forms a layer on top of lead 2 carbonate. And that layer cannot allow the reaction to continue to take place. So what do? The moment you add like this, you see 2, 3, 4 bubbles, and the reaction does what? Stops. Why does it stop? Because of formation of lead 2 chloride, which is insoluble, forms a protective layer and stops the reaction from further taking place. So this is the scenario. From general to specific, citing a few anomalies that are available. With this information, 1, we have revised reactions of hydrochloric acid as an acid. Number 2, it has pushed out the chemistry of salts of hydrochloric acid. And beyond that, we'll look at general methods of preparation of salts. So if you have captured this, I want us to go to the next scheme, which is supposed to be used as a summary to prepare these salts, but even other salts beyond chlorides. Because with sulfuric acid shall come back and I'll still tax you, and I'll still task you to prepare again sulfates. The same method will come back. At this time, I may not write on a chalkboard, on a whiteboard. I'll just sit and instruct, explain how you can prepare A, B, C, D. You must use the scheme we are having today to get what you want. So instead of hydrochloric acid, shall be putting what? Sulfuric acid. Shall get respective what? Sulfates, and shall be picking out a few of these things that we think are not necessary. So allow me at this moment in time, ladies and gentlemen, my dear students, to erase the whiteboard. Then we write down a simple scheme that's used to prepare these salts. It is not in the notes that were sent on the web. No. Here we are now in for question, presentation, interpretation, outside the notes that were given. So I'll expect that each one at least writes down this scheme. And at one time I'll ask you, when we come together face to face, I'll ask to produce that scheme. So let's look at preparation of soluble chlorides. General scheme. Call it summary. Summary of preparation of soluble chlorides. So I'm looking at a summary for preparation of soluble chlorides. Summary for preparation of soluble chlorides. Summary for preparation of soluble chlorides. My work is in the form of outlines, and that's what I want. So outline number 1, you write the following. Warm, dilute. So let's put there the acid and underline. To warm, dilute. Hydrochloric acid, comma, underline hydrochloric acid, because in general discussion I'll delete the acid and insert another acid, which can be sulfuric acid, which can be nitric what? Acid. So underline hydrochloric acid. To warm dilute hydrochloric acid, comma, add dash little at a time while stirring until in excess. When no more solid dissolves. That's the first statement. Now ask yourself, I want you to ask yourself wherever you are, why do you add excess solid until in excess? Why? There must be a reason. Why do you think should solid be in excess? Why do you think the solid should be in excess? To remove all the acid. So why in excess? I tell you in chemistry, every statement you utter must have a supporting reason. So why do I add in excess? To remove all the what? To make sure that the reaction has taken place up to the end. Others will end up with an acid which has a salt which has an acid in it, and it becomes dangerous. Salts are supposed to be neutral. Now you're bringing a salt which is acidic. So why? Ask yourself, but why? This is your personal work, but why? The purpose to remove all the acid. To remove all the acid. We shall see what that dash is. Step number 2. Let us go to step number 2. In step number 2, what you do? You filter off the excess dash. Filter off the excess dash. Filter off the excess dash. I want you to check what is the difference or what's the similarity between this dash and this dash. When you read that statement, you will see. The statement says to warm dilute hydrochloric acid, add dash little at a time while stirring until in excess, when no more solid dissolves. The purpose of adding that in excess to remove all the acid. Filter off the excess dash. What is the similarity or what's the difference between this dash and this dash? In your own thinking. I'm giving you time to think and reason before I give my answer. Now you have respective answers. Let me give my opinion and you find out. Similarity and difference between this dash and this dash. If there is a similarity or there is a difference, what's there between those two dashes? This dash is the same as this dash. Because you added this one here in excess and that refers the one you are removing. So once you have captured this dash, then you know this one. The one you added until in excess, the one you are removing. So you are removing the one which did not react. So this dash is the same dash. What appears here is what's going to appear there. Full stop. If you want, you can come in with your equation. So step number 3, equation. Equation. Write equation. Because I want my student to get the 7, 8 marks in this number. Number 4. What do you get when you filter? You have 2 things. In the senior 1 chemistry, what do you have? A filtrate and a residue. What is the residue? The residue is the undissolved what? Solid. Which was in what? Excess. Do you need it? No. What do you need? The filtrate. What's the filtrate? What passes through the filter? Paper. So we're interested in the filtrate. So what should we do now? We shall gently boil the filtrate. Why do you boil the filtrate? Gently boil the filtrate. Why? Ask yourself why. The filtrate to drive off excess water. We boil the filtrate to drive off excess water until the solution or the filtrate becomes what? Concentrated. So what's the purpose of boiling? To drive off what? Excess water. Activity and the reason. So that you obtain a concentrated solution. Have you ever prepared a meal and you put salt as you cook? What happens? The quantity of salt in the sauce begins what? To increase with the continuous cooking. Why? Only water evaporates, leaving the salt behind until the sauce becomes too tough with sodium chloride. Senior 1 principles, evaporation to dryness. We shall not evaporate to dryness because the salt can end up getting what? Decomposed. So you drive off excess water until your solution becomes too salty. That's when you know it is concentrated. If it's sauce, you can't now eat it because it's too salty. It is now concentrated. And in most cases, what do you see when the solution is concentrated? You see particles begin to form on the sides of the container. You know the solution is concentrated. So that is the next step. So I am addressing what I call my points only. Alright. Let us see what follows next. I'm going to remove the upper statement because of the size of the board. So I'm going to step number 4. Step number 1. Acid, add excess solid while stirring until no more dissolves. Filter off. Equation if you can. Gently boil. After boiling, what is the next step? You allow the hot concentrated solution to cool. Allow the hot concentrated solution to cool. Why? To cool in order to deposit crystals. If you don't allow it to cool, it doesn't deposit what? Crystals. So you allow the hot concentrated solution to cool in order to deposit crystals. You allow the hot concentrated solution to cool in order to deposit crystals. So why are we allowing it to cool? The reason is to deposit what? Crystals. There is a reason embedded in the statement. Allow the hot concentration to cool, full stop. Why? To deposit crystals. Now, sometimes there is an equation that can be written. Sometimes there is an equation. Sometimes there may not be an equation. There's with equations, with an equation. But let's put the provision there so that you will choose. My last statement. Now you have crystals. What do you do next? You filter off the crystals. Filter off the crystals. What do you do? You wash them with some. I want to make sure you understand why should it be little, some little, and why should it be cold, and why should it be distilled. Some cold, little cold distilled water. What are you doing? You are purifying. Isn't it? To purify them. And after washing and purifying them with some chocolate water, what's the next thing? You dry. Dry the crystals. Between filter papers. Full stop. I want you to think, without being told, why should the crystals be washed with some little distilled water, moreover cold? Why don't you use a lot of water? Why don't you use hot water? The salts are going to dissolve. They are soluble salts. But you have an element, maybe there is an impurity and you want to remove it. So they might use a lot of water to happen. All the crystals will end up what? Dissolving. Supposing you use hot water, crystals are more soluble in hot water. That's why we use cold water. Have you ever put sugar in the water that you have picked from a refrigerator? That the sugar dissolve readily. But can you put the same sugar in hot water? Does it dissolve readily? That is it. Salt in very cold water doesn't dissolve readily. In hot water, warm water, salt readily does what? Dissolve. So common salt at all. That's the principle. So why is some little cold? To reduce on solubility. This is the scheme complete. May I now address the first dash? What's the first dash? The first dash can be a metal. The dash can be a metal oxide. The dash can be a metal hydroxide. The dash can be a metal carbonate, as designed as required in the question. In most cases, the dash is specified. So NB, and I end this session, we shall think of one salt, NB. This one, in quotes, the dash. is filled with a metal. It can be a metal oxide. It can be a metal hydroxide, or it can be a metal what? Carbonate. In most cases, that dash is given in the question. So what do you choose? You choose the what? The acid. You now choose the what? The acid. So, I want to think of a metal as an example without writing. Without writing. But follow the scheme from the beginning and see. I've chosen my metal as zinc. So what is my essay? My essay becomes to warm dilute hydrochloric acid, comma, add zinc little at a time while stirring until no more solid dissolves. Full stop. Filter off the excess zinc. So what is my equation? So my equation is zinc plus hydrochloric acid. Zinc is a solid, hydrochloric acid is aqueous. What did we note? A metal and an acid, zinc chloride. So zinc chloride, which is aqueous, plus hydrogen gas. But remember, the zinc added was in excess, not the whole of it did what? Reacted. So I need to filter off the one I was filtering off. So my filtrate is zinc chloride. Hydrogen has gotten what? Lost. My residue is unreacted what? Zinc. I forget about the reacted zinc. I continue with the zinc chloride as a filtrate. So what was our next statement? Gently boil the filtrate to drive off excess water until the solution is concentrated. Next step. Allow the hot concentrated solution to cool in order to deposit crystals. What followed next? The equation. So what's the equation now? The equation now is zinc chloride as a hot concentrated solution. When it cools, it will attract some water molecules into it, which we call water of crystallization. I don't know, this value can be any value. Let's just imagine the value is 4. So plus 4 moles of water, a liquid. What happens? We shall get zinc chloride dot 4 moles of water. This is a solid. So anything we call crystalline, crystals, is rough qualitative analysis and has water of crystallization in most cases. So this is what we are obtaining now as a solid. So this equation may not be very important. The most important equation is the first one. That's why I say, let's say equation, you write this one. Unless it is open that you can come in and write this one, what does it mean? You need to know the value of water. If you don't know the value of water, what do? Please, you omit the value of water and therefore omit this one here and just say aqueous is changing it to solid if you don't know the value of water. That's why the first equation becomes the most important equation. If you know the value of water of crystallization. Sometimes in the question it is given. Describe how. For example, iron 2 sulfate. They say iron 2 sulfate, FeSO4. 0.7 moles of water is prepared. What are they telling you? The final equation, you need to say iron 2 sulfate aqueous plus 7 what? Water. Because it has water of crystallization which is specified and known. So from here what do? Wash the crystal with some little cold, distilled water, and press them between the filter paper to dry. Why don't we heat to dryness? When you heat to dryness, what happens? The crystals become powders. Some of them decompose to form what? Oxides. And therefore you have lost in the game. I want crystals of zinc chloride, give me zinc oxide. So you have lost. So this is the scheme. Supposing I'm preparing from zinc carbonate. What is my answer? To warm, dilute hydrochloric acid, add zinc carbonate little at a time while stirring until no more solid dissolves. Filter off the excess zinc carbonate. The remaining stories will continue. I feel like preparing for me Nabucco chloride from Nabucco oxide. The issue is not the name of the salt, the issue is the scheme. If it's Nabucco chloride, I need hydrochloric acid, and I've given me Nabucco oxide. So first dash, Nabucco oxide. Second dash, Nabucco oxide. Equation, NB, if it stands for Nabucco, it is NbO. It may be if that's one group 1. If it's group 2, is NbO. If it's group 1, Nabucco is group 1 element. What's the name of the oxide? It is that one, Nb2O. And therefore you can write hydrochloric what? Acid. What will be my product? Oh, I'll have NbCl, and this is a 2, aqueous. What else I'll obtain? Water. So I need 2 moles of this. I mean you continue. So the name of the salt is not the major issue. The issue is the choice of the acid and picking on either a metal oxide, a metal carbonate, or metal hydroxide. And I stated in most cases the dash is given in the question. Having prepared the salt, they push you into an element of qualitative analysis. Either effect of heat, like that. Are we there? So, I think I cannot prepare sodium chloride from sodium and hydrochloric acid. Reaction is explosive. But I can prepare maybe sodium chloride, maybe from sodium oxide. There is also a method called titration. We shall see when do we use titration as a special method of preparing salts. So this method is very good for salts of group 2 other than group 1. So we are through with this method. So assignment. Describe how magnesium chloride crystals, let me put the word dry. Magnesium chloride crystals can be prepared in the laboratory from magnesium carbonate. Full stop. NB Sodium chloride and potassium chloride are preferably prepared by titration. So I'm putting to be discussed later. Why am I saying it will be discussed later? I need to introduce volumetric analysis. You will understand me. So when it comes to volumetric analysis, I'll take you back and say this is a method of preparing sodium chloride. But in most cases, what we're interested in is these other salts other than sodium chloride. When you can prepare from a metal oxide, a metal hydroxide, and a metal carbonate. This one calls for titration, which is a subtopic of its own. Because here I'll be talking to myself. You may not understand when it comes to titration completely. I'll be mentioning apparatus that are new to you. Indicator until the end. What's the end point? So this one I'm referring, and it's allowed. That's why when it came to chemistry of water, hardness, removable hardness in senior 1, we waited. We shall now complete hardness in water in senior 4, because there are more concepts you have covered. In our last discussion today, we are going to look at the third method of preparing salts, and we shall be in position to subject ourselves to questions, because we have about 30 minutes, and therefore 20 minutes are supposed to be for questions, to be interactive. So let us look at preparation of insoluble salts. So preparation of insoluble chlorides. What are those insoluble chlorides? Lead 2 chloride and silver what? Chloride. Good. So we are saying that these are, so we are noting that this is PbCl2 and AgCl. So they are prepared by the people in the studio. What is this one? Precipitation. So what is a precipitate? A precipitate is an insoluble solid, insoluble salt formed when two solutions are reacted together. A solution plus a solution, you get a solid. That solid is called a precipitate. And we have ever seen this. So it means adding two solutions together, you end up with a solid. So we prepare these two solids by precipitation because they are insoluble. Reactions in most cases end up what? Stopping. So to make sure the reaction goes up to the end, what do? You not only to mix what? Solutions together. So what is one of the solution? One of the solution already is hydrochloric acid. We have to look for another soluble salt that has the cation, because hydrochloric acid will produce a chloride ion. Who will produce the red ion? Who will produce the silver ion? We look for a soluble salt. So a chloride will come from hydrochloric acid. So where will it come from? We must look for another salt that dissolves, that should generate the red ion. Alright? So here we look for a soluble salt having a cation. We add to hydrochloric acid. So in the notes we are saying precipitation, they are prepared by precipitation, full stop. So we use a soluble salt solution having the cation. Soluble salt solution having a cation is reacted or is mixed with what? Dilute hydrochloric acid. Full stop. So we think of this. So which salts do you know are soluble? Very soluble. Quickly, so that we have the remaining treatments for the discussion. But sulfate has exceptions. Chlorides have exceptions. Carbonates have exceptions. Nitrates. So in most cases, all these salts therefore they are prepared from nitrates because all nitrates are soluble. So we shall add, having the cation, let's say especially from what? Nitrates. So NB, nitrates are used. Nitrates are used because they are all what? Soluble. Because they are all soluble. Because all, language may not be very good. Because all are soluble. So let us use the following scheme. Summary. Summary. 1. I want to erase this so that my summary can also flow. So let me remove this so that I begin writing. I hope you have captured those outside there, not in the studio. Please capture those statements. The statements are your notes for revision. All right. Number 1. To dash comma, why nitrate solution? All nitrates are soluble. So to dash nitrate solution, comma, we are going to add unequal volume and concentration. Add unequal volume and a concentration of what? Of dilute. Which acid? Dilute. We are preparing chloride, so dilute hydrocholic acid. You are noting something small, that equal volume and equal concentration. Solution plus solution. When you do that, what happens next? What will follow next? When you add, you start to mix and for complete reaction to take what? Place. So it is followed by stir or stir the mixture for complete what? For complete reaction to take place. We got milk into porridge. What do you do? To mix very well. It's the same thing here. So as they're mixing, precipitate is forming. So there must be an equation that will follow step number 3. This equation can be ionic, the equation can be molecular. We shall see. From there, what follows next? There are two things, a solid and a solution. The solid, because you are forming insoluble salt. So what do we do next? Filter. Next step is filter off. Filter off the insoluble salt prepared. Filter off the insoluble salt formed. That is obtained as a residue. Do you do that in the lab? Yes. And after that, what follows next? You wash the residue. This time we don't use little. What do we use this time? Excess distilled water, because the salt remains insoluble. So wash the residue. With excess cold distilled water. So what is the last step? That will be the last step. You now, this time you don't heat. You can heat, fine. But I think shall go for general, you spread the solid. The residue to what? To dry. Full stop. Spread the residue to dry. Spread the residue to dry. So if I want lead 2 chloride, what do I put here? Lead 2. And I can write the equation. If I want silver chloride, silver nitrate. And those are only 2. Either lead 2 nitrate or silver nitrate. If I want a sulfate, what happens? This one becomes sulfuric what? Acid. I can put barium nitrate, barium sulfate. I can put lead nitrate, lead sulfate. I can put calcium nitrate, calcium sulfate. So these are the basic principles that we do use. So if I want to prepare lead 2 chloride, so what do I put here? If I want lead 2 chloride, therefore I'll put here what? Lead 2. The word nitrate is already there. Solution. So what will be my equation? My equation will be lead 2 nitrate, which is aqueous, plus hydrochloric what? Acid. Aqueous. What does it give us? Lead 2 chloride, which is a solid, but shall have what? Hydrogen, and nitrate will give us plus what? Nitric acid. Do you see why I need a lot of water to remove all the acid? The balanced equation, 2 chlorines, here it is 1. And therefore what do? I put a 2 here. There are 2 nitrates here, there's only 1. So I need a 2 here. This is aqueous. Do you see why we are filtering to obtain lead 2 chloride as a residue? Do you see now we add excess water to wash down all of the residue and remain with a pure nitrate? Now this one, even in the lab, you can squeeze the filter paper. You can spray and to dry. You can put in an oven. Even if you put it on a dish and left dryness, it doesn't what? Decompose. So the method of drying is not a major issue. Any method you choose will work because they are stable. Then doesn't decompose very much you heat it. It doesn't. Thermally stable. So in the case I want an ionic equation, which is the cheapest? Which is the cheapest here? Let us see. If I want an ionic equation from our usual style, Lead 2 nitrate produces lead 2 ions, aqueous. It also produces 2 moles of nitrate ions that are aqueous. This is what we are seeing as lead 2 nitrate. Plus, hydrochloric acid will give us 2 hydrogen ions from a balanced equation, aqueous, plus 2 chloride ions, which is also aqueous. When the two mix, what are we obtaining? Lead 2 chloride, which is a solid. The 2 ions are holding one another, so they will come as one solid, PbCl2 solid. Plus, nitric acid ionizes to give us 2 moles of hydrogen ions, aqueous, plus 2 moles of nitrate ions, aqueous. In our usual style, we remove the spectator what? Ions. So what are these spectator ions? I'm seeing a nitrate here, and I'm seeing a nitrate there. I'm seeing hydrogen ions, I am seeing hydrogen ions. So what is my overall ionic equation? So, the nitrate introduced lead ions, hydrochloric acid was introduced in producing chloride ions, and the two are giving us lead 2 chloride, which is a solid. This is the method we refer to as precipitation method. So if I want silver chloride, silver nitrate, hydrochloric acid. So what is my equation? If it is an ionic equation, from silver nitrate, what am I obtaining? Silver ions, aqueous. From hydrochloric acid, chloride ions, aqueous. So what's the product? Silver chloride, which is a solid. So that one summarizes the preparation of insoluble salts. So I've used the hydrochloric acid today. In the next lesson topic, I'll be using sulfuric acid. In the previous one, we used nitric acid. That's why we say when you follow concepts, one concept introduces you to another, and the things are capable of flowing systematically. As you prepare yourselves for sulfur and its compounds as our next topic. All right. So I think what is following next is supposed to be time for questions, because we are aware we're supposed to be using some few minutes to interact in the form of questions. Prepare your questions. Questions. So, think of the questions. If you have any, it's your time to send your questions so that we can give a response, because we have limited time. We have about 6 minutes only. But please do the assignment, because before I introduce the next topic, I should be pushing to listen to your queries where you have gotten hiccups, and we see, because we are moving to the next topic, sulfur and its compounds. Please prepare. If the lab is accessible, probably shall see qualitative analysis of what? The chloride, which we covered before you went home, but does no harm if the office can allow, and we redo it. Time for questions. There's nobody who has raised a question as yet. What does it mean? Total understanding, or we are totally lost? Which of the two should we take? Even those in the studio, please, you're supposed to be asking. Studio students, any query? You are comfortable. Wonderful. Those in the studio are saying everything is halal, which is okay, fine, according to their language. Right. So since there are no questions, it gives me pleasure, and I can quickly judge, because we looked at properties of hydrochloric acid. They are the same properties we are using in the preparation of these salts. And all along this information I've been following it right from the time we introduced qualitative analysis to you. So if you have been following the work up today, I think that's a wonderful thing. So thank you for being good students. Prepare yourself for the chemistry of sulfur. Other than the assignment I've given you, I want you to go and look at number 1, atomic structure on sulfur. I want you to look at isotopes of sulfur. I want you to look at bonding in sulfur, group and period. Then from there shall jump and go to occurrence of sulfur and extraction of sulfur. 1, atomic structure on sulfur and bonding. Number 2, occurrence of sulfur. Number 3, extraction of sulfur. Those are quite very many things, but if you have done some prior reading, we shall be moving relatively faster. I think we shall be able to achieve our objectives. Thank you so much. Assalamu alaikum.